All right. I currently work at VirtuStream. It's a Dell EMC company, and but about 5 years ago, we were part of EMC before the big merger. And we were running what was basically a science experiment for EMC to try to build a cloud object store. For network engineers, that might not be particularly interesting. It was measured in petabytes, and it was on the order of hundreds of switches. And we were operating that in a very traditional manner. Even the network design was fairly traditional with a core distribution layer and typical network engineering traditional methodology. Suddenly we won a big contract, which was great and also really scary. We went from operating at a kind of medium-sized scale to operating at a fairly large scale. In almost overnight, we were asked to build out lots of data centers that involved thousands of switches and eventually grew to in the order of many exabytes of potential storage, usable storage, ingesting over a terabyte per second, 24/7. It was an interesting challenge and something that we were not prepared for. It was also a bit of a perfect storm that we had just attended a Cisco Live and we heard some talks about POPE. We were like, what is this? Power on auto provision thing? Bootstrapping gear in an automated fashion. We also were surrounded by the SRE teams, and, the compute teams and the storage teams that were operating in a DevOps/SRE methodology. And as traditional network engineers, that was something fairly foreign to us. And so we were kind of pushed off this cliff of, you need to learn to swim in this new world or you're going to die. And so that led us down this path of, let's start trying to automate our bootstrap process. Of course, with the idea that maybe someday we would go further than that. But that's where we started, and that's the process that pushed us into this world. I don't know where you are in your journey as far as DevOps, if you use it at your company or not, if you're writing code or not, but this is our experience and what we went through, and hopefully, if you aren't doing it, maybe this will encourage you to move in this direction. If you are doing, maybe there's a tip that we have here that might be helpful for you. The dream we had. Click the easy button and the network's configured, right? We want the NOC to be able to onboard a new tenant or a new customer or push out a Mac without bothering any network engineer, right? Like, we just want the network to be configured. That's a good dream. The reality is probably not going to happen, right? We've got varying vendor support for various methods that you can push changes out to the network gear. We've got multiple competing frameworks to use. Literally nothing is off the shelf that you can use for the network gear, right? And there simply is no easy button. And this was the challenge we faced with that process, right? We also were learning about what does automation mean versus what is orchestration, right? And just from our perspective, we found and clarified for us that orchestration is the process of codifying your process. So it doesn't really necessarily change what you do. It's just taking your process and putting it in a code form. That's cool, but that's not really all that much, right? Automation is really where it comes in, and this is when we start codifying tasks. So this is individual things that a human used to do that now we put into code and human doesn't do it anymore. We can layer our orchestration on top of that and have orchestration then put those tasks into flow for us, right? So this is just stringing together our various bits of automation. So an overview, right? We have the bootstrap process, and this is where we're just deploying new gear out. In our experience, what we were doing, we were taking about 2 weeks to deploy a couple of hundred switches with 2 people. And it was very time-consuming, tedious work. By the time we got to the end of it, after implementing the automation that we had, we were able to do several hundred switches in a data center in 4 hours with 1 person. That's from nothing to fully configured and validated as well, which would include all the cable validation that we wrote doing that in an automated fashion. So it was a very interesting experience to go through this process of taking something that used to take a really long time with a lot of man hours and being able to do it in a very short time just through automation. The other pieces that we wanted to add in would be able to have for operation for standards, moves, adds, and changes, And then, of course, device configuration that we can push out and keep in a templatized fashion, store it up in Git, whether it's in whole or in part, and maintain our versions so that we can have the version control on that. We can have peer review, we can have source control, et cetera, that you can get through that process of keeping it in templatized form in Git. While we were doing this experiment, right back then in the early days, for us at least, there was a lot of talk about Puppet when we went to Cisco Live, and so that's where we started. We started using Puppet, which had some advantages, some disadvantages, and then as we moved further along, we started to use other tools. We experimented with things like Salt and Napalm, eventually ending up on Ansible, which is mostly, it seems to be what everybody is kind of using at this point today. Of course, not everybody, but we also started then layering orchestration on top of that. For us, we use StackStorm, but there are lots of other options. Rundeck is one of them. And so there are these various tools that you can use to implement your automation. The challenge we found was, how do we get the data into the automation? Because it doesn't start from nothing. It has to have some seed data that starts all this process, right? So we had like really, really bad solutions. Do it by hand, which is what we did at first. Lots of copy paste. Statically define it in code. Also really, really bad. This is difficult to maintain. It doesn't scale. Still not so great. Putting things in spreadsheets, sending emails. This was another option we were doing. We were using Google Docs for a while as our spreadsheet. Not such a great option either, right? And then finally, the disconnected tools, right? This is where we ended up for a while. So we have disconnected things like IPAM, and then our CMDB, and our DCIM, right? So all of these various databases that are maintaining duplicate data and having to be re-entered multiple times. So the problem here we found was like, so we've got to enter some information in IPAM, and then we've got to duplicate that re-entry over in the CMDB and in the DCIM because it's the same device. You're putting in the FQDN over and over again. You're trying to redo this data and keep it in sync. And of course, once you put something in more than one place, it's never going to match, right? Like you're always going to have it to be different. So we finally stumbled on like, we need a single source of truth. We need a single place where we keep all of this data for everything that we have in the company. And we started asking around, going to conferences, asking people, how do you do this? And other hyperscalers would say, we do that, but we can't talk about it. That's intellectual property, it's a secret, we're not allowed to discuss it. So we started, well, I guess we have to build our own. So this is where we went, right? Today, there are some other solutions that you might not have to build your own, but the path we went down, fortunately, we had a Postgres engineer that was available to us, so we were able to start down this path. The goal, though, was to take all of the disconnected tools and make them connected and establish these rich relationships between data that used to be disconnected. So now we could have a relationship between the device and its logical resources like IP addresses, VLANs, VRFs, ASNs, and the physical world as well. So the data center it lives in, the site address that it's in, the rack and the pod location that it's in, could all be maintained in one central place where we have these relationships between these various bits of data. What data did we want to store? So I was just alluding to those, right? We want to have the physical and virtual devices. And in our case, we wanted to have everything, not just network. We wanted to have all the compute, all the storage, everything that was in the data center should be in this database. Everything that was physical in the data center, it's a link, it's a cable, it's a transceiver, it's a power supply, it's a hot standby that's sitting on the shelf and not even racked, or a cold standby. We also wanted to have all the logical data. So again, all of our IP addresses, all of our VLANs, ASNs, VRFs, et cetera. Every bit of data that we contain, whether it's physical, virtual, or otherwise, should be in the database. So now we can take all of that data we have and create relationships between everything and use it to actually be able to retrieve values from the data in an automated fashion. And we can create resource pools to distribute that data, right? So rather than having to say, I'm going to allocate out VLANs 100 to 120 for whatever, I can now just create a pool of VLANs 100 through 120. And when I need one, go ask for one. It's a really different way of thinking about how to use the data, particularly I think for network engineers, because we always want to be like really handcrafted with our packets, right? We want to know that VLAN 100 is only used for whatever, and we want to know that IP address 1.1.1 is very special. But really it's not. It's just a resource that we need to make the network function. So some source of truth examples, right? Like this is some options. Even today, it's still quite DIY, I think, in my experience. Like, you've got various databases like Mongo and Postgres. You've got some slightly other, more proprietary options like PuppetDB or Hiera. And then, of course, relatively simple, but maybe not so great to use would be YAML or JSON files. A little bit back to the data entry problem if you go this route. And now today, finally off the shelf, there is something. It's maybe still not fully developed or possible, but with NetBox. This was interesting for us that we had been developing our internal system, and about maybe 2 or 3 years after we had gone into production with ours, we saw NetBox become open source, and we started looking at what they had done, and we're like, that's basically the same as what we built. This is a really funny experience to see like, okay, other people thought the same way we did, had the same problems, and solved them in almost exactly the same way, using very, very similar terminology and process. So this is an example of a possible database schema that you might look at for your source of truth. This isn't the detail that we have in ours. Unfortunately, the lawyer said, no, you can't share that. So we have to give you something fairly sanitized. But hopefully it gives you an idea and maybe sparks some thoughts about how you might do this. Hopefully this is big enough that you can see. We started thinking about in a very device-centric world, right? Like where the device is the center of the universe, essentially. So if you look in the center of the screen, you can see we have devices. And note that it's not network devices, right? It's all the things. And it doesn't matter whether it's physical or virtual. We should be able to model it and store it in the database and keep it there so that we have a record of it. Of course, if it's an ethereal device, one that you don't necessarily care about, you might not put it here, but these would be devices that you do care about that do stick around. So we list all the appropriate pieces of data for that device. Particularly if it's a physical one, we're gonna have all the physical aspects, like the rack unit that it's in and the site that it lives in, et cetera. And while we were building this, what we found interesting is that as we moved from vendor to vendor and we use different vendors' equipment, maintaining the different types of interfaces and the way that vendors name their interfaces with the inconsistency of that across brands, and even sometimes within brands, is a huge challenge. So we split out the concept of an interface into a separate table and kept that separately so that we can model the appropriate equipment with the appropriate interface type. And under the interface is where we keep all of the appropriate information related to the port. So its speed, whether or not it takes a transceiver, and what its port number is in that vendor's parlance, et cetera, would be down there in the interface section. On the left side of the screen, it tried to represent the physical infrastructure. So we have the sites, the rack information, the links, et cetera, right? And then on the right side of the screen, we've got the logical information, VLANs, networks first, right? This is just an example. Obviously, in your case, you might have more, you might have less, whatever the data. You would probably immediately think of other tables that should be there. You say, why don't we have that? It's just a simple example, right? But I hope you can see from the diagram that we're trying to take what traditionally would have been very, very separate databases and put them into one place, where you can now store all of this data together instead of having your disparate pieces of information. So if we take a look at a practical example of what we could do with this kind of data, suppose that we were asked to deploy a new physical server that's running some web servers. So we're gonna have some physical requirements that we need in order to do that. Right? We need to know that we've got to get some switch ports available on some access switches that we're gonna plug this server into. We're gonna have some cabling requirements that we've got to give to the DC ops team to go out and actually do the cabling. We're gonna have logical requirements. We need some VLANs. We need some public internal and management IP addresses, and maybe we need an FQDN. So just some various bits of data that we need, along with some physical things that need to happen. A brief aside. We all have, or many of us probably have a pet. Fluffy, what have you. We love it, we name it, we care for it. When it gets sick, we take care of it. And you may have heard this before, but this is the classic pets versus cattle. So Fluffy we care about. And when we love her very much, and when she finally is very, very sick, we take her to the vet and we make sure she gets better. Cattle, on the other hand, we don't really care that much about on an individual basis. Right? If a cattle gets sick, do we take it to the vet? Probably not. We shoot it in the head and we get a new one. And so this is the approach, the difference between pets and cattle, right? We don't care about the individual. And we need to think of our resources in the same way, whether it's an IP address, a VLAN, a switch port. Why do you care about it on an individual level? Right? My resource is special. I need to name it and pet it and love it forever. And the answer to that is no, it's not. No, you don't. Treat all your resources as cattle, every single one of them. Anything you have that you allocate out, it's cattle. It is not a pet. Do not love it. Don't get attached to it. This is a really important thing, I think, when you make the transition into an automated world. You have to stop treating your resources as pets, because if you do, you will fail drastically. You cannot operate in an automated fashion, in an idempotent fashion, if you care about your resources on an individual level. You care about pools. You want to have resource pools. You do not want to have individual resources. This is from our experience, what we learned, right? And you can apply the same concept, by the way, to your rack units. Why do you care where your switch is installed in the rack on an individual basis? Does it really matter? Put your rack units in pools and allocate them out that way. The compute can have rack units, 1 through 15. Storage can have 20 through whatever. You can have 35 to 48. And then just allocate out from your pools. Why do you care about the individual rack unit as an example? Okay, off my soapbox. So from your resource pools that you can now create in your single source of truth, you can programmatically allocate out almost everything you have. So it's your rack units, your switch ports, your logical resources, right? Your VLANs, your IP addresses. These can all be allocated in an automated fashion that your code can now take care of. We can automatically potentially generate things like the request off to DCOps to go and do this cabling. We can generate the cut sheet that DCOps needs in order to do the cabling work in an automated fashion. We can give them an automated rack elevation so they know where to stick the gear in the rack. We can generate our network configuration in an automated fashion as well. We can potentially create DNS entries in our DNS servers, all through the automation. What we have ended up at this point now is using Ansible and Python as our two main drivers for how we drive our automation. Some advantages we found with Ansible, it's got a really short learning curve. We started off with Puppet, which has a medium-sized learning curve. And we ended up in Ansible primarily because it's agentless. Not having to have the agent that's required in Puppet is much simpler when we come to deploying on network gear, where traditionally we don't have access to the underlying operating system. Obviously that's changing, and now we often do now. But still, I think the agentless model is much simpler, particularly for a network equipment. It's open sourced, and there's fairly broad vendor support. Virtually all network vendors support some form of Ansible connectivity at this point. And we have various Ansible modules for almost every major vendor. Python, most common language probably. Probably depends on what religion you belong to. But for us, we found Python broadly supported. And again, virtually every network device now has some kind of Python interpreter on it, if you actually want to run Python code on your gear. It's pretty human readable. Obviously, we should be writing documentation and we should be putting comments in our code, but we all know that doesn't happen. So it's nice to use a language that if there isn't commented properly, you can look at it and fairly easily read it. And it's very broadly supported. So looking at how you could actually use Python code in your Ansible play, right? So this is where it starts to get interesting, because now we can use code to go do a lookup into our source of truth, and in an automated fashion, can enter data into the configuration. So we have This is not, at least in my experience, was not particularly obvious. There is a defaulted folder under the Ansible configuration called filter plugins. And this is where you can stick code that you want to get access to in your plays. So you could create something like myfunctions.py in the filter plugins folder, and you will now be able to access those functions in your Ansible play, in your Jinja template, if you're familiar with Ansible. So this would be a simple example of a J2, of a Jinja template that could be used in Ansible. And it's just writing a very static, fairly static config. But as opposed to having some actual data in there, we're doing lookups into our database. So here we're just configuring interface, Ethernet, not sure yet, because we're going to get it from the pool. And in this case, we've written a little function called allocate pool. And it's going to take two variables coming into it, or two inputs, the FQDN of the device and the pool name, which in this case is web servers. The Jinja formatting for receiving incoming variables is a little bit odd. The first one comes before the pipe, and then second and all following come within the parentheses. That's just a little strange nuance of Jinja. And then down under the VLAN, we're also going to get it from a pool. And in this case, its inputs is going to be the site, and again, a pool name of web servers. And let's just no-shut the port. Back in the myfunctions.py file that we created up in the filter plugins folder, we can now have our actual functions defined. Obviously, this is pseudocode because I don't know what your database is and what it's going to look like, but you would essentially write some Python code in there that gets access to your database. That could be a class maybe that you've written and also have up in myfunctions, so you could include classes in there, and then access that code here in your function. So in the case of allocate port, we're going to take those two incoming parameters, and we're going to go into the database, look up the appropriate pool, get an available port to use on the switch, and then return it to the code. And the same for the VLAN, right? We're going to go look up that VLAN, find an available one in the pool, and return it into the Jinja template. So Ansible will take over, and we're going to use Ansible now to input the variable information. So we've got the FQDN of the device and the site information. And we're going to ask Ansible to take that Jinja template, the mytemplate.j2, and we're going to produce myswitchconfig.config. So this will be where we use the automation to now generate in an automated fashion and allocate out of our resource pools the actual configuration that can be applied to the device. So this would be an example of that. We can then take further layers of this. So this is one example of automating a simple task of going and configuring a switch port in order to install a server. We could layer orchestration layers on top of that to do this several more things. We can allocate out multiple configurations for multiple switches, and we can then configure Ansible to continue down this path of actually deploying this configuration. Now, you might want to include in your orchestration, you might want to have some pauses. For example, you want to go through peer review. You want to go through change control. You want to only do it at 3 a.m. in your change window. This can all be configured into your orchestration as well. And it just depending on your particular environment and how you do it. So in review, basically Ansible broad network support. We would highly recommend it if you aren't using any form of automation today. It's relatively simple and easy to get started with compared to other platforms. And because of the agentless methodology, it doesn't require much to actually start playing with it. Some things you can do with it. You could take a snapshot of your gear before you actually do the deploy. So you have a backup in case of needing to roll back if there's a problem. There are multiple methods you can use to deploy the config out to your gear. Ansible can use SSH or API-driven methodologies. You can save the changes, obviously, to the gear, as well as you can save the changes off into GitHub as well if you wish, if you want to maintain your configurations in some flat file form. And you can also roll back. Right? So that's the summary of what we've learned and what we've done. Any questions, comments? And we will be at our table as well in the lunch area, which is coming up shortly. So if you want to ask us more questions and follow up there, you're welcome to.